Let's start by choosing u. We're going to choose u to be arctan x. You may recognize this function as inverse tan x. It's written both ways. And then dv is what's left over, and in this case, that is dx. On the left-hand side, we are going to differentiate. The derivative of arctan x, if you remember, is 1 divided by 1 plus x squared, and then we have our dx there. And then on the right-hand side, we're going to integrate dx, and that just gives us x. Let's put aside the definite integral for a minute, and let's just solve the indefinite integral. So we're going to solve the indefinite integral arctan x dx, and we'll use our integration by parts formula. This is uv minus the integral v du, and remember that this part is just our integral u dv. Let's multiply u times v. That gives us x arctan x, and then we're going to subtract off the integral of v times du. Our v is x, and then our du is 1 over 1 plus x squared dx. Now, we're not out of the woods yet. We need to integrate this integral right here. You might recognize that we can integrate this by using u substitution. We're going to let u be 1 plus x squared, and then du is equal to 2x dx. I'm going to come over here to the left. This gives us x arctan x. That just comes along for the ride. And then we subtract off the integral. X dx, that's right here, is going to be du divided by 2. And then 1 plus x squared is just u. So this is x arctan x minus 1/2 the integral 1 over u du. I'm writing it like that so that you can recognize that integral. That integral is the natural log function. So this is x arctan x minus 1/2 natural log, don't forget the absolute value, u plus c. Now let's go ahead and let's plug back in what u is. So this is x arctan x minus 1/2 natural log. Now, let's go back up here to the right-hand side at the top. There's our u. Notice that it's 1 plus x squared, so it's always going to be positive, so we can drop the absolute value sign. And this becomes 1 plus x squared, and then we'll put our plus c there, but in a second here, we're going to get rid of that. What we're going to do is go back to the definite integral. We were asked to solve the integral from 0 to 1, arctan x dx. So now we're going to write down exactly what we just got. Let me highlight that in blue here. That's this part right here. And we're going to evaluate that from 0 to 1. So this becomes x arctan x minus 1/2 natural log 1 plus x squared. And then our x is going to go from 0 to 1. And our plus c goes away. So let's plug in first that x is 1. So this becomes arctan 1 minus 1/2 natural log 1 plus 1 is 2, so that's natural log 2. Then we subtract off our lower limit. X is 0, so our first term is 0. And then we have a minus 1/2 natural log of 1. Natural log of 1, that goes to 0. So we're just left with our first two terms. And our answer is arctan 1. To find that answer, you have to think about What angle, remember an arctangent is always an angle. For what angle is the tangent 1? And that's pi over 4. So this becomes pi over 4 minus 1/2 natural log 2. And that's our final answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.